Guys, today we're going to solve this problem in division 2, right? Its rating is 2000 and it's posted by a dash, right? So let's begin. As always, we are going to introduce this problem by explaining the example here. So we have two numbers in the input, right? 6 means the number of rows in the following two-dimensional array, and 5 means the columns in the following two-dimensional array, right? So it has 5 columns and 6 rows, right? And this number will be very small. It's from 1 to 8, right? And this number can be very large. So for the two-dimensional array, it will have very limited number of columns, but very large number of rows, right? So that is very important for us to solve this problem. And what's the output here? 1 and 5. So let's explain the output. So 1 and 5 means in the output, we are going to choose two arrays, the first array and the fifth array. So now we got two arrays, right? And then we will calculate the maximum of each index. So for the first index, 5 is bigger than 2, so we got 5. And for the second index, 3 is bigger than 0, so we got 3. For the third, 3 is bigger than 0, get another 3. For the fourth, 6 is bigger than 1, so we got 6 here. So for the last index, 3 bigger than 2, got yet another 3, right? So we got a new array here. Then we are going to find the final minimum, which is the minimum value in this array, which is 3, right? 3 is the minimum value in this array, so we got 3. So this final minimum number is a result of choosing these two arrays, right? And we are going to calculate final minimum for each pair of arrays in this two-dimensional array, right? We are going to calculate the first array with the second array, and then we choose a pair of the first array with the third array, etc., right? So we can get a lot of final minimums here, right? And then we are going to choose the minimum from those. Actually, we are going to choose the maximum value from those final minimums. So we got a max minimum here, which is 3, right? So in the output, we can just output a pair that result in the max minimum, right? We can output any pair of it, right? So how can we solve this problem? We are going to do this with binary search, right? So let's find out the max minimum first. So the maximum minimum is surely in the range between 0 and 10 to the power of 9, right? Because all these numbers are in this range, so the max minimum should be in this range as well. So we're going to choose this number, which is the mid in this range, to check if it can be the max minimum, right? So let's say this mid here is 5 multiplied by 10 to the power of 8, right? So let's first check if this number can be the max minimal. So of course it cannot be, right? It's too big, right? If it cannot be the answer, we are going to choose a smaller one, right? And check if the smaller one can be the max minimal. So if the smaller one is still too large, we're going to check the even smaller one, right? The even smaller one is the mid of the this range, right? So if this number can be the max minimal, then we're going to try a larger one, which is in this range, and we are going to try the middle point in this range, right? And eventually we can convert into just 1 point. So that 1 point can satisfy the condition of being max minimal. So that number is our max minimal. So we can just output an arbitrary pair of arrays that has can result in the maximum minimal, right? So this process takes around 100 times, right? It's quite small. We can just run the binary search for 100 times, and we can find the max minimal. So the real question is that how can we check a number if a number can be a max minimal? So that's a tricky part, right? So let's discuss it right now. So first, let's say we are checking 3. We are checking if 3 can be the max minimal. So first, we are going to convert this two-dimensional array into a Boolean two-dimensional array, right? We are going to change it into this one, right? So because we are checking if 3 can be the max minimal, then we are going to compare each of the number with 3, right? If it is bigger than 3, 5 is bigger than 3, then we put a 2 here, or we put a 1 here, right? So if this number is smaller than 3, we put a 0 here, or false here, right? And 3 equals to 3, so we put a 1 here. 1 is smaller than 3, so we put a 0 here. 2 is smaller than 3, so we put a 0 here. In the same way, we do this for each of the numbers, right? So 6 is bigger than 3, so we have a 1 here. 4 is bigger than 3, so we have a 1 here, right? So in this way, we got this two-dimensional array. So this two-dimensional array is very interesting because it's in binary form. So we can easily transform an array into a number, right? Because we at most have 8 columns here. So we can easily transform this array into an integer number, right? And there are very limited number of integer numbers. It's at most 2 to the power of 8 numbers here, right? So we have 5 multiplied by 10 to the power of 5 rows here, right? We can have many rows, but those rows can convert it to very limited number of states, right? Let's say, for example, this guy can convert it to a integer, right? So this is the binary form of that integer, and let's convert it. So the integer equals to 0 multiplied by 2 to the power of 0 to the power of 1, right? And plus 1 multiplied by 2 to the power of 2, then 0 multiplied by 2 to the power of 3, right? And plus 1 multiplied by 2 to the power of 4, which is 19. So this guy transform into 19, right? So I hope I'm right. So if I am wrong, that's okay, right? I'm just demonstrating the idea here. So we have many arrays here, but we can convert those arrays to at most 2 to the power of 8 number of integers, right? And we can use those integers to check if we can, let's say we got this array and this array. So we check if when we apply OR operation on these two integers, right? We apply OR operation on these two binary form integers. Then what we got? We got for this index we got a 1. For this index we got a 1, right? For this index we got a 1. For this index we got a 1, right? 1 or 0 equals to 1, right? For this integer we got a 0 here. Interesting. Okay, so this pair doesn't satisfy the condition because the OR operation result we are looking for is OR 1, right? If we can find a OR 1 array, that means the maximum of each integer are all bigger than the max minimal. Then their final minimal equals to the maximum minimal, right? So here is where we try the first array with the last array, right? So let's try the first array with the fifth array, right? So for the first index we got 1. The second index we got 1. Third index we got a 1. Fourth index we got a 1. Fifth index we got a 1. So all ones here, right? So it means the maximum of each integers are all bigger than the 3 here. 3 is what we compare to for each numbers in this two-dimensional array, right? So there at least one of them is bigger or equal than 3 for these two arrays, right? So we find the pair here, right? And we can be sure that 3 could be the max minimum, and we can return the result for the checking method and we can continue on the binary search part, right? So that is how we solve this problem. So let's look at the code, right? Here is the code. So it has two parts. The left part is where we run the binary search, right? And the right part is where we check for each number to see if it could be the maximum minimum, right? So let's take a look at the left part first. So this part is where we read all those numbers in the two-dimensional array, right? And O1 is an integer that its binary form are all ones, right? So we are going to generate this integer here, and then this part is where we find all the pairs that can generate O1 by applying OR operation, right? Let's say if we have two columns, our goal is to generate 1 1, right? And the pairs we could have is 0 1 and 1 0, right? So let's say the first array in binary form is this guy, and the second array in binary form is this guy. So this pair can result in the all ones pair, all ones form, right? So we apply a OR operation on these two binary. We can get 1 1, right? So this part is where we find all those pairs, right? And here is where we run the binary search. It is pretty straightforward. So this is the initial value of left and right, and we are going to choose the middle point for each iteration, right? And we are going to check the middle point in each iteration. And if it's too big, we are going to search for the actually, let me see. So this part is where the number we are using is too big, right? So we look for the next number in the first part of the range, right? And this is where we find that the number we are using could be the maximum minimum. So we are going to look for the actual value in the second part of the range, right? And in the end, we are going to output some pairs that can generate the maximal minimal value, right? And this part is where we check if this number can actually could be the maximum minimum. So first we are going to convert. This is where we convert the two-dimensional array into binary two-dimensional array, and at the same time we are going to convert each array into a state, into a single integer, right? And we are going to mark that integer as existed, right? So in the future, we are going to use the existed integers to find out if we can find out a valid pair, right? And when we find a valid pair, we are going to return this pair, right? And we are going to output it, right? So I guess that's it. Thank you for watching.